Hey there, geometry students. Hope you enjoy the review of the group test here, and I'm definitely hoping that you do very well on the exam here in the next couple of days. So starting out, IC1, translations. We've got an original image of 8, -2, and we want to use the translation x plus 4, y minus 1. So the image would be a prime. You're going to add 4 to 8, you get 12. Subtract 1 from -2, and you get -3. And then what is the pre-image of d prime, which is at 6, 5? Well, then you're going to kind of do the opposite. The original d, instead of adding 4, you would subtract 4. So 6 minus 4 is 2. And instead of subtracting 1, you would add 1 for the y, and you get 6. All right, IC2, again, using some translations, verifying that a translation is an isometry. Well, first of all, what is the translation? Well, you're going to be moving, starting here at 7, so like if we took a look at A, moving 1, 2, 3, 4, 5, 6, 7 to the right, so 7, and then down 6, 1, 2, 3, 4, 5, 6. And so we get 7, -6. But to verify that it's an isometry, well, we're going to basically show SSS. Well, AC is congruent to A prime, C prime. They're both 4. You can just count and verify that. Same with CB and C prime, B prime. That's 2. If I do the Pythagorean theorem or the distance formula, I can find AB and A prime, B prime, which of course wind up being 2 radical 5. And so, since I've got 3 congruent corresponding sides by SSS, these two triangles are congruent. For IC3, just going ahead and adding, subtracting, multiplying matrices here, we're just adding them, so just add the corresponding spots. You get 6, 2, -6, 2, 1, and 8. And then here, we're multiplying matrices. So if I've got a 2 by 3 and then a 3 by 1, the 3's match, and they'll cancel out. And you're going to be left with a 2 by 1. So I set up a 2 by 1 to begin with. And then if I want the information in row 1, column 1, I multiply row 1 by column 1. So I have 0, 0, -1. And if I want the information in row 2, column 1, I multiply row 2 by column 1. So 0, -1 plus 1 would be 0. All right, solving real world problems. I think in one of those cabinets over there, I've got a Bible.
Must I have in my room or like?
No, yeah, somewhere in there, probably. Okay, so in this case, we've got two companies, KT and Ole, and they're purchasing planners, desks, and pens. Over here, we've got planners are $8, desks are $90, and pens are $5. Remember that you're going to want to kind of do all of this in one matrix, not separate, two different matrices or matrix multiplication things. So I'm going to set this up cost. So this would be a 3, or I guess a 1 by 3, and then this will be a 3 by 2. And so the 3's will cancel out, and you'll have, you know, the individual planner, desk, pens, planner, desk, pen, those will cancel out, and you'll wind up with the cost for KT and Ole. So this is cost for KT and Ole. Well, again, this is going to be a 1 by 2, so you've got 1 by 2. So row 1, column 1, I multiply row 1 by column 1. I do all 3 of those things, I get 670. Then row 1, column 2, I multiply row 1 by column 2 and add up each one of those 3 things, and I get 890. So that's how I want that one to look. Let's see, for IC5, change this one up just a little bit. The first one is the same. X equals -2, so you've got the line that goes through the x-axis at -2, and then you're just going to reflect over that line. So if you're 2 to the left, you'd be 2 to the right. And if you're 3 to the right, it'd be 3 to the left. Connect your dots, and you're done. This one, let's see, I believe it was the x-axis. So you had to pick the right matrix there. You're going to want to make sure that that matrix is on the left to your matrix that has your 3 coordinates there. All right, IC6 gave people some fits, but it was a different proof. So I don't know what to do about that. We'll just say, make sure you've got 3 of these proofs. So you've got the one where it's right on the line, okay, and for that you're using LL to prove that these triangles are congruent. You've got the one that's over the line, and that's the one that we did in the warm-up today. And so that one's basically like 2 versions of this one, but including the segment addition postulate and substitution, so you can see how those connect. And then the third one is the one that you had on the exam, and that's the one where they don't even come close to the line. And so you've got to kind of piece these things together. You make your own set of triangles. You want to prove that this one is congruent to that one, and you'll do that by LL. That's exactly the same as this. That'll give you these congruent, and then by definition of reflection, you'll have those 2 congruent. You need one more piece to show that these triangles on the outside are congruent, and you're basically going to show that these 2 are congruent. I would suggest using alternate interior angles and the super transitive property. So this is going to be congruent to that by AIA, and this is going to be congruent to that by CPCTC. You just show that these 2 triangles are congruent. This is congruent to that by alternate interior angles, and so by transitive property, this to this, this to this, this to this, these 2 are congruent. So that's by side angle side that these 2 are congruent. And so that means if these 2 are congruent by CPCTC, these 2 have to be congruent. So in general, that's the 3 types that you have, and you'll get one of those 3 on your exam. All right, IC7, again, having to use a matrix, and so your matrix here for a rotation of 270 would be, well, it's 0, 1, 1, 0. That's going to flip them, but you want to change the sign on the second one, so you got the negative for that. Excuse me, and then you're going to go ahead and put in your matrix. So you've got 2, negative 4, and you've got 7, negative 6. And so as you go about doing your matrix multiplication here, you got 0, negative 4, and negative 2, 0. And you can see that not only have they been switched, but you changed the sign on the second one. And then here for the second one, we've got negative 2, 0. Or sorry, row 1, column 2. So we've got 0, negative 6, and negative 7, 0. And that should put us 270 degrees over here. So negative 4, negative 2, and then negative 6, negative 7. All right, and then using a compass and a ruler to rotate. In this case, you're rotating 150 degrees around point P. So again, you're just going to be taking each individual coordinate and rotating it 150 degrees. Use your compass to make sure that this distance is the same as that distance. And then you're going to do that for all 3 of your vertices and connect them, and then you're done. All right, that's first half of the group test. We'll do the second half of the group test in a different video.